Today we're going to continue working on the tangent line problem. It's very important to distinguish the slope of a secant line versus the slope of a tangent line. The slope of a secant line always uses 2 points. For this, you can just use algebra to be able to figure out these problems, and it gives you the average rate of change on an interval. On the other hand, the slope of a secant line uses calculus because it involves the idea of a limit, and it uses 1 point. It's also called the derivative, and it gives us the instantaneous rate of change. So, for example, you might go an average speed in your car over a certain time interval. Maybe your average speed was 50, but at an exact instant, you could be traveling at exactly 60 miles an hour, or exactly 40 miles an hour, or 42 miles an hour. And they're very different ideas. So we'll look at that with a few problems today. We're just going to use the definition of the derivative as a limit. There's a couple different definitions we'll get to, but for now, to find g prime of t, we're going to use the limit definition. So we have g of t plus h minus g of t all over h. If you don't like the t, change it to an x and then fix it at the end of the problem. Okay? Either way, it doesn't matter to me. Plug in what you have. Oops. So instead of writing t, we replace everything with t plus h. And then we minus the whole g of t function. Okay, for this, I would multiply everything by the two denominators, the least common multiple of both denominators. And remember, we could do this because we're just multiplying by 1, so we're not changing anything with the function. Alright, so this we're just going to get in the numerator t plus h times t plus 1. Okay, this one will get t times t plus h plus 1. In the denominator, we have h times t plus h plus 1. T plus 1. Great. Alright, distribute all of this out. So we have t squared plus t plus th plus h minus t squared minus th minus t. If you look, a lot of things should cancel out. More than likely, everything in your numerator should have an h in it. Alright, so we have this part gone, this part gone. Alright, so in the numerator, we just have an h. So then we're left with, actually I could go down here. Alright, so I have an h in the numerator and an h in the denominator. So I'm going to go ahead and cancel that out. So I have 1 over t plus h plus 1 and t plus 1. As h goes to 0, I end up with 1 over t plus 1 quantity squared. So that gives us the slope of our function. Okay, the derivative function g prime of t at any point. Alright, so part B now. Part B asks us to find the equation of the normal line. Now remember, normal is perpendicular. So if we find the slope of the function at 1, okay, so 1 over 1 plus 1 quantity squared, 1/4. The slope of the normal line is going to be the negative reciprocal of that, or the opposite reciprocal of that. For the equation of a line, we need a point and a slope. Right now, we just have the slope. So plug 1 into your g function. You get 1 over 1 plus 1, or 1/2. Now we could go ahead and write our equation. Y minus y1 equals m times x minus x1. Again, you can leave it just like this, or you can write it in slope-intercept form. Now, on the AP exam or any of my tests, unless I specifically ask for the slope-intercept form, you are more than welcome to just leave it like this. It's much simpler than trying to distribute it. Now, if you distribute it and you add something incorrectly, your problem's now wrong, where it's better to just leave it alone. All right, so, two people, Leibniz and Newton, both kind of co-discovered calculus, but they were approaching it using two different perspectives. So Leibniz notation we're going to be using, and Newton's notation we're going to be using, but one of them had asked the question about instantaneous velocity. Okay, so Newton figured out that the change in position is velocity, okay, like miles per hour. The rate of change of velocity is acceleration. So we're going to have that relationship between position, velocity, and acceleration, and you'll be seeing that very often. With this, this is a classic calculus problem. A ball is thrown into the air so that its height is, after t seconds, is given by this equation. So it's going to look something like that. All right, during the first second, what is the ball's average velocity? Now, since that says average, we're just trying to find the slope of the secant line. Okay, we can think about that. During the first second. All right, so h of 1. Plug in 1, you get negative 16 plus 20 plus 8. I believe that would be 12. Let's find h of 0. That would be 8. Average velocity. Change in y over change in x. I'm just going to write that out. Okay. So the average velocity, h of 1 is 12 minus 8 over 1 minus 0, 4. Do we have units? Let's see. I'm going to go with feet per second here. Okay, that's our average velocity. Now, part B says at exactly t equals 1 second, what is the ball's height? Well, we already did that, didn't we? 12 feet. Well, that was an easy one. What's the velocity at specifically that second? All right, now velocity is given by the derivative of the slope function. All right, so the only way that you know how to do that officially right now is by doing the limit definition of the derivative. So h prime of t equals the limit as h approaches 0 of, okay, this is h of t plus h minus h of t. Again, if you don't like these letters, just change them. So I have a long process here of writing this out. I'm probably going to run out of room, no big deal. Minus all over h. Oops. All right. So I'm going to simplify here, distribute everything out. Negative 16 t squared minus 32 th plus, minus there. Hopefully you can read all this. And that's all over h. Okay, lots cancel out. We have 8 and 8, 20 and 20. This part, that does not cancel out. All right, so now it looks like I'm going to factor out in h. Oh, they do cancel out. Okay, factor out in h. I get negative 32t minus 16h plus 20. Cancel out the h's, let h approach 0. And we have h prime of t equal to minus, that should be a 20 there. There we go. So that's the velocity function is equal to that. So now the specific velocity at 1 is going to be negative 32 minus, oh, it should have been a plus 20. Glad I caught that now. All right, negative 32 plus 20, which will be negative 12 feet per second. That's our velocity. All right, and last part is acceleration. Acceleration is simply the derivative of velocity. Okay, I'm going to do that on the side here. This time, remember, we're using the velocity function. So we have negative 32 t plus h plus 20 minus negative 32 t plus 20 all over h. Simplify that, and you get negative 32. Okay, just as a function. If you need help simplifying that, just talk to me. So the acceleration at 1, or at any point, is negative 32 feet per second squared. All right, we covered a lot of information. It's not too much. I think you can handle it. Try a couple of your example problems and have a great day.